Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is depreciation. What you're going to learn today is how to find the derivative of one of the basic functions, that is the trig function. So let's begin. After completing the very lesson today, my dear student, will be able to find the derivative of the trig function. This is what I hope you'll be able to do after completing the very lesson today. So as usual in your favorite segment of the lesson, today I'll give you another interesting and amazing number. This number is nothing but the 17. 17 is so interesting, so unique. I will explain what is special about this very number after completing the lesson today, so don't go away. To begin the lesson, let us first take the rules that will guide us how to find the derivative of this trig function. So let me start with the very first rule. The first rule says if you have the function y equals to sine x, you can see this is a trig function because it involves a trig ratio sign here. So derivative of sine x, what happens is nothing but the derivative of this sine x is nothing but cos x. Rule number 2, it says if you have function y equals to cos x, you can see also this cos is a trig function. So the function y is a trig function. Derivative of cos is nothing but minus sign. Similarly, number 3 rule, it says if you have y equals to sine ax, this sine ax is different from sine x. Here is just like you have sine 1x, which we don't usually write. But if you have, for example, sine 2x, where a is any real number there, so the derivative of sine ax is nothing but a cos ax. So if you have sine 2x, for example, that the derivative will now be 2 cos 2x. Similarly, rule number 4, if you have y equals to cos ax, where a is any real number, so derivative of that cos ax is nothing but minus a sine ax. So in that case, if you have, for example, cos 2x, derivative of that cos 2x would now be minus 2 sine 2x. These are the guidelines, these are the rules that we have to obey in attempting to find the derivative of a trig function. So let me just move to the examples where we will now apply these rules. Example number 1, it says find the derivative with respect to x if you have the function y equals to sine 5x. Solution to this very problem. What we do first is just to attempt to write the rule of sine ax. So the rule says if you have d by dx of sine ax, you wanted to find the d by dx of sine ax. This is nothing but a cos ax. So in this case, the dy by dx, that is the derivative of this function y, which now is equals to sine 5x. So will now be equals to d by dx of sine 5x. So you can now compare this 5 with a. Here, look at it, sine ax, sine 5x. So your a is now 5, and the rule tells us that this is nothing but a cos ax. So in this case, it is now going to give me 5 cos 5x. So this will now be the derivative of the function y. That is dy by dx will now be 5 cos 5x. Let me take another example. Example number 2, it says find the derivative with respect to x if you have the function y equals to minus 2 cos 3x. Solution to this very problem. So what we do, I will now write the rule that will guide me to find the derivative of cos ax. That rule says d by dx of cos ax is nothing but minus a sine ax. So in attempt to get dy by dx, that is the derivative of the function y with respect to x, d by dx will now be equals to d by dx of minus 2 cos 3x, minus 2 cos 3x. So I'll now compare minus 2 cos 3x with my cos ax. So in this case, you now take cos 3x, this 3 is now your a. So this 3 will now multiply this minus 2 that I have already. So then I'm going to have minus 2 times minus 3 sine 3x. minus 3 sine 3x is what gives me the derivative based on this very rule, minus a sine ax. So I'll now multiply minus 2 by minus 3 to get a positive 6. So that gives me 6 sine 3x. This is the derivative of the function y. Let me just take one more example. Example number 3, we asked to find the dy by dx if you have the function y equals to sine x minus cos 2x plus 1. Solution to this very problem. So what I'm going to do, dy by dx of this very function will now be equals to d by dx of the very first term sine x minus d by dx of the next term, that is the second term, which is cos 2x, plus d by dx of the last term, which is this constant number 1. So I'll continue. Derivative of sine x. Sine x is nothing but cos x. Then derivative of cos x, remember, is minus a sine ax. In this case, your a is 2. So we are going to have minus the 2 sine 2x. And the derivative of constant number in our last lesson, properties of depreciation, we learned that derivative of constant number is 0. So derivative of 1 is nothing but 0. So I'll continue. This minus will now change it to plus. That is what I'm going to do in the next step. So I'm going to have my cos x plus 2 sine 2x plus 0. I'll just leave it. So this is the derivative of this function y. With these few examples, I have come to the end of this very lesson, my dear students. I hope with this, you'll be able to find the derivative of the trig functions. Thank you for your attention, and let me just move to the last segment, MathsClass. So what is interesting about this very number 17? The number 17 is the same as the sum of digits in its cube. That is, if we are to find the cube of 17, add those digits in the cube, it will give you the number back. Let's find out. So 17 raised to the power of 3, that is 7 cube, 17 cube. This, if you compute it correctly, it gives you this number 4,913. And if you are to add those digits in this number 4,913, it will give you the 17 back. Let's see 4 plus 9. This gives you 13. 13 plus 1 gives you 14. 14 plus 3 gives you 17. So this result will now be 17. So 17 is so special in such that if you are to find the cube of that 17, the result, you add those digits in the result, it will take you back to your original number 17. We see more of this amazing things in mathematics in our subsequent lesson. Thank you for your attention.